Now, in this video, we are going to take up one more problem on projections of lines. Two lines capital AB and capital AC makes an angle of 120 degree between them in their front view and top view. AB is parallel to both HP and VP. Determine the real angle between capital AB and AC. So this is a very straightforward problem, but he has not given any inclinations with respect to it is not given any length with respect to both HP and VP, and he has not given the point above distance with respect to both HP and VP. But he says it is parallel to both HP and VP, and he asked find the real angle between capital AB and capital AC. So this is the real angle what I need to find out. What is the real angle means? It is the true angle what you will going to get. So now we need to identify, or now we need to draw this, how to analyze this problem. So here, first we want to draw the XY line and we mark VP and HP, which is as shown. So as he has not given any distance with respect to both HP and VP, so from XY line you measure some distance and you draw a horizontal line. And similarly from XY line you measure some distance with respect to XY below XY line and draw a horizontal line. And consider any point, and from here you draw a vertical projector so that you are going to cut these two horizontal lines here. And similarly from A, and you mark this point as A dash, and you mark this point as A, and this as capital A, and this as capital A. Once you do that, so from the end projected A, you take some distance and you draw a horizontal line, vertical line, and so that it will going to be cutting both this above XY line and also the below XY line. And you mark this point as B dash, and you mark this point as B, and this as capital B, and this as capital B. So say AB is parallel to both HP and VP, so now the condition is satisfied. But it can be taken any distance because he has not given any distance. And he has given the distance, so this becomes capital A and this becomes capital B. So the distance between the real makes an angle of 120 degree between their front views and top views. So this is the front view and this is the top view. So from A dash, by using the protractor, you measure an angle of 120 degree and draw an inclined line. Similarly with A as center, by using the protractor, you measure an angle of 120 degree with respect to the horizontal and then draw an inclined line. As we got this inclination, now I need to, so since it is 120 degrees, so this from B also you should get an angle which is equal to 30, and this angle is also 30. So that the total sum of the three angles of a triangle will be equal to 180 degrees. So from B dash, by using the protractor, you measure an angle of 30 degree with respect to the horizontal and then draw an inclined line. Similarly, with A dash as center, by using the protractor, you measure an angle of 150 degree and then draw an inclined line. Both these two angles will going to cut at this point, and you mark this point as C dash. Then join A dash to C dash, B dash to C dash, and A dash to B dash with a dot line. So now from C dash you draw a vertical projector to the top view, and similarly with A as center with respect to the horizontal line AB, you measure an angle of 120 degrees and then draw an inclined line. Similarly with B as center, by using the protractor, you measure an angle of 30 degree with respect to the horizontal and then draw an inclined line. Both these two lines will intersect such that this will go to be the point C. And when we have drawn the vertical projector from C dash, and both these two will going to intersect at this point, so you mark this point as small c. If it is not intersecting, then you are making some mistake. So this is how you can be able to draw the initial front view and top views of the given problem. Now we need to find the real angle. Real angle means it is a true angle. So we need to find out the true length of these three lines, that is A dash B dash, B dash C dash, and A dash C dash. You want to find out the true length. But we already know that A dash B dash is parallel to HP, so we are getting the true length in HP. Similarly, AB is the line which is parallel to VP, so A dash B dash is already in true length. So I need to find out the true length of AC, and also I need to find out the true length of BC. So what we need to do is through A you draw a horizontal projector below XY line parallel to XY. Then by using the compass with A as center, taking the radius of AC, you draw an arc such that it will see C1 and you such that this it will going to cut the horizontal line, extended projector line from A. So you mark this point as C1. So then AC1 is the line which is parallel to VP. Once you get the AC1 line parallel to VP, then you are getting the true length in VP. So from C dash you draw a horizontal dash dot line, so which will going to be the locus of C for the remaining two lines. Then from C1 you draw a vertical projector such that it will going to cut the locus of C here, and you mark this point as C1 dash. As we have start with A center, we are taking the radius of AC and we are rotating. So obviously that C1 dash should be joined to A dash with a little thin line, because that will going to be the projector line. Then similarly you need to identify the true length of B dash C dash. Why? Because BC is also inclined. Now with B as center, by taking the radius of BC by using the compass, you draw an arc such that it will going to touches the AB line which is extended here, and you mark this point as C2. Then from C2 you draw a vertical projector such that it will going to cut the locus of C here, and you mark this point as C2 dash. Then join B dash C dash B dash C2 dash with little bit thicker than the XY line. So we were able to find out, because A dash B dash is already in true length, we were able to find out A dash C1 dash, which is again the true length, and B dash C2 dash is again the true length. So now we have found out the individually the true length of AB, BC and BA. But what we want is to find the true angle between capital AB and capital CC. So with B dash as center, taking the radius of B dash C2 dash, by using the compass you draw a thin arc. Similarly with A dash as center, taking the radius of A dash C1 dash, by using the compass you draw a thin arc such that both these two arcs will going to cut at this point. You mark this point as C3 dash. Then you mark this point as capital C, because this is the true inclination. So then join A dash C3 dash and also B dash C3 dash with little bit thicker than the XY line. So then by show the angle here which is theta, then by using the protractor with A dash as center with respect to A dash B dash line, you measure an angle with respect to line A dash C3 dash. So that angle will going to become theta. So when you are doing it in manually, it will be 112 degrees. When you are doing it in computer, it will going to be 112.21. So this is the true inclination with respect to HP. So you mark this point as capital C. So the real angle between capital AB and capital AC will going to be the theta, which will be 112 degrees manually. So this is how we will be able to solve this problem in projections of lines in the sketchbook. Thank you.